Well, hello there, Addie, and welcome to the first day of school. This is going to be awesome. I am so excited for us. We are going to start advanced math, and congratulations to you for finishing your math for last year. Good job. I know you had to work over the summer and it was super hard, but you know what? You are going to be so far ahead. I promise you. You are doing awesome in math. This first lesson, I hate to kind of tell you this, but this is going to be a little long, and the reason is because this first lesson assumes that you know everything in the world that there is to know about geometry. And just to make sure that you know it all, we're going to do an entire review of all of geometry in one lesson, just to make sure you know it, because you're going to definitely need to know it for this advanced math, okay? So pay attention to all the concepts that we're going to go over today and make sure that you know all of these things by heart. First of all, it was only a minor earthquake, but the Etch-a-Sketch gallery was ruined. Oh no, look. What do you think was on those? I kind of picture like the Mona Lisa on them. Oh, that would be sad. All that work gone to waste. Okay, let's just jump right in. This is going to be awesome. The first thing that we're going to do is learn about points, lines, and rays. So these are terms that you need to know and that they're a little bit tricky to define. And when they are hard to define, we call them sort of primitive terms or undefined terms, but we're going to define them the best that we can, and then we're going to use them to define other terms. So it's important that you know them. The first word that you need to know is point. Okay, I'm going to point to the point. Okay, that's the point right there. You put a dot on a piece of paper to mark its location, but the dot is not actually the point because a mathematical point has no size. It's super small. The dot does have a size. So a dot is more like the graph of a mathematical point that has no size. Isn't that cool? It just marks the location of the point. Now, if you have an unbroken connection of points, let me get out the little laser pointer. Okay, if you have an unbroken connection of points like this, then you are going to have a curve. So a curve is an unbroken connection of points. Okay, and since points have no size, they can't really be connected. Therefore, we prefer to say that a curve defines sort of the path traveled by a moving point. Okay, so that's what a curve is, the path traveled by a moving point. And you can use a pencil, of course, to graph a curve. These figures are all curves, right? Couldn't they be? Couldn't a point be moving across all of these? Yeah, a curve could do that. Why not? So you can call all of these curves or lines. Okay, a mathematical line is a little bit different. A mathematical line is a straight curve. Isn't it weird to think of it as a straight curve? But if you define a curve as a path that a point will take, then sure, you can have a straight curve. The point can go straight. A mathematical line is a straight curve that has no ends. So look at this picture here. The arrows indicate that it has no ends. Only one mathematical line can be drawn that passes through two designated points. So if you have a point here and a point here, you can only draw one line that goes through those 2 points. Okay? Think about that for a second. That's kind of interesting. All right. Now, you can name a line by using a single letter. Like in this case, this is line P, right? Because we gave it a name. We called it line P. You can also name a line by using any 2 points on the line in any order. It doesn't matter. So this could be line, here are a bunch of names that it could have. It could be line AB, it could be BA, it could be AM, it could be MA, BM, like bowel movement, or MB. Okay, these are all names for the same line. And so as long as you put 2 points of that line, then it's the same line. Okay? So, and that's how you would call these. If you see something like this with an arrow over it, that means line BA. Okay. If you have just a part of a line, so instead of arrows, you have points at the end of it, then this is called a line segment. It's just a segment of a line. So a line contains the end points contains point A, it contains point B, and it contains all the points in between the endpoints. And if you see something like this is segment AB, this is segment BA. Okay? All right. Whew. Okay. The length of a line segment. How would you designate the length of it? So if you were to measure the line segment, you can say AB without this bar over it, and that is referring to the length. So if it doesn't have the bar over it, then that means it's referring to the length. So you might say something like AB is equal to 5 centimeters, and that makes sense because it's referring to the length of between the point A and B, and that is 5 centimeters. Okay, when you use the words equal to, greater than, or less than, when you use any of those symbols, those are really only used to compare numbers. Okay, so if you say that, if you want to compare line segments, then you don't use those words, you use a different word. Okay, so these are only used for numbers. If you want to compare line segments, you would say that they are congruent. If they are the same, then they're congruent. So here in this example, if these are the same, PQ is congruent to RS. I know it's kind of silly because you don't call them equal when congruent means that they are the same length. So PQ is equal to the length of RS. Anyway, they're just called congruent, but it means that they are equal. Okay, so you could say line PQ, and if I'm saying line, if I'm saying segment PQ is equal to RS, these are congruent. This means, let's see, this indicates congruence. The equal with the wavy line over it, that means congruent. Okay. Or you can write, if you want to say that their lengths are equal, then you could write it another way. And this is just, I know, PQ, this Q, is equal to RS. Because remember, when there's no line over it, that means you're referring to their lengths, and you could say their lengths are equal because that's a number. Okay. All right, let's move on because that's kind of silly. Okay, let's talk about rays. A ray is sometimes called a half line, and the reason it's called a half line is because it has one point right here. So one of them is an endpoint, and then the other side has an arrow, which means it goes off forever in that direction. It'll just keep going and going. I think of a ray as like a ray of sunshine, and if you draw a sun, then all of those things coming out from it are rays. They have this point, and then it keeps going forever in that other direction. So that's how you can remember that this is called a ray. It has one point and one arrow that goes on forever. Okay. And when you want to indicate a ray or name a ray, you can call it by any two letters, but we usually start with the one at the origin. So start with the T, and then it could be TU, and that's a ray. And it has an arrow with just one arrowhead. Or it could be TX, and that's the same ray. So it's ray TX. So the only rule is just you start at the origin, but you can use any other point, and it's the same ray. All right, let's move on to collinear. Collinear means two rays of opposite directions that lie on the same line. Okay, so it's collinear. Co means the same, like a co-pilot. You're still a pilot, so you're the same. Collinear means you're on the same line, but it's going to indicate a ray on the same line. So what does that mean? That means that the ray XM, so if we start with M, X sorry, if we start with x and go to xm, this ray and xp are opposite rays, but they're collinear with this line. So you can say ray xm and ray xp are collinear with the line mx. Okay, that makes sense. Let's move on. What about intersection? If two geometric figures have points in common, we say that these are points of intersection. So this is a line, goes off in both directions. This is a line E, goes off in both directions. They both have this point Z, that is on both of the lines. Point Z is on line B, point Z is also on line E. That means they have a point in common. This is the intersection between those two lines. Intersection. Now, if you have parallel lines, by definition, they never cross each other. If you have parallel lines, they would have to be perfectly straight. That means they are never going to cross each other. This could go on forever around the Earth, like the equator of an Earth. And if it had two equators, they would never ever cross each other. They just keep going around in that perfect circle parallel to each other. So parallel lines never intersect, but all other lines do. If it's not parallel, it has to intersect at some point, even if it's 200 miles down the road. Okay, hey, Addie, we are moving on, and now we are going to talk about planes. Nope, not airplanes. This is a mathematical plane. Remember that a mathematical line is a line like this, and it has no width, and it continues without end in both directions. Okay, so that's a line. A mathematical plane can be thought of like a flat surface, like a tablecloth. But what's cool about it, it has no thickness. It's like razor sharp skinny, like a tiny, tiny sheet that goes on all in one flat plane, like a tabletop. It continues without limit in the two dimensions that define the plane. And so you can think of a plane that as it has no edges, but you often draw a plane using a four-sided figure. But really, it might go on forever in all of those directions. Okay, so this is plane P and this is plane Q. Now, just like we have to have 2 points and they determine a line, you have to have 3 points to make a plane. If the 3 points are perfectly parallel to each other, that's just still going to be a line. So the 3 points have to be non-collinear. That means not in the same line. And as long as they're not making a line, they make more like a triangle, it's going to be a plane that all the points are on. Okay? So 3 non-collinear points determine a plane. All right, now let's look at these planes. On the right, we see that this plane has 2 lines on it. And you can also determine a plane with 2 lines. So 2 parallel lines also determine a plane. These are parallel, so that means they'll never touch each other. And you can say both of those lines are on the same plane, plane S. Okay? So you could make a flat surface out of 2 lines. Okay, a line that's not in a plane is parallel to the plane if the line does not ever intersect the plane. Okay, so let's look at this picture. If you've got a line that's not in the plane, but parallel to the plane, it doesn't intersect the plane. If a line is not parallel to the plane, then the line is going to intersect the plane. So that's like this line. This is invisible because it's like on the other side of the plane. Okay, so here the line is crossing the plane or it intersects the plane. It's going to intersect the plane only at one point. In this figure, the point is indicated by point P. Okay. So line F intersects the plane. Line C is parallel to the plane, so it never touches it. Okay, skew lines are lines that are not in the same plane. Skew lines are never parallel and they don't intersect. So a skew line, I guess it would be like, I don't know. It's not parallel, but it doesn't cross the plane. Okay, so let's see if line K, thus lines K and F in the diagram above are skew lines because they're not in the plane, because they're not both in plane M, and they do not form another plane because they're not parallel and they don't intersect. Oh, so these lines, okay, so it's just saying that these lines are skew to each other because they're never going to intersect. They're never going to cross each other. This would be like, if you have to think of it as a three-dimensional space, because it looks like it crosses, the lines cross right there, but they don't, because this one's in front of this one. So you have to think of it as a three-dimensional space and see if that makes sense to you. So these are skew lines to each other. They're not parallel and they don't intersect. Okay, let's move on to angles. An angle is a geometric figure that's formed by two rays, and they have a common point. So this is one ray, this is another ray. The angle is this. Okay, you got it. You could also say that the angle is the region, or this region that is bounded by these two lines and by the arc of the circle. So if I filled all of that in, it would be this. And that region is also, you could think of that as the angle. Okay? Alrighty. Whew. Let's do a few more vocabulary words here. There's just things that you need to know. Okay, the angle here, we've got an angle O. Here's your ray, here's your ray. It's a 30-degree angle. This is going to be your initial side. You can think of the angle as starting here and maybe it moves up, right? So let's say I draw a line like this, and then I don't know if I can grab it, but I grab it. I don't know if I can grab it. I meant to like grab it. Okay. I meant to grab it and then like make it go up like that. like that. You use your imagination. I'm grabbing it and moving it up. Okay, so this would be the initial side where it starts, and that's the terminal side where it ends, and the angle is in between those. Okay, there's another angle when we look at this 30-degree angle, and you could also be talking about this angle, all the way around that's left. And remember that a circle is a 360-degree angle, so this would be 360 minus the 30 degrees, that other angle. If you took this angle, let me get a different color, started here and went all the way around and went to the terminal side again, then you overlap these areas and it would be 360 plus the 30 degrees. Tell me if that makes sense. Okay. All right. Let's... Okay. Yeah, they're just showing the difference between these two angles. Let me show you one more time. So this is the initial side is B, the terminal side is M. So there can be two angles formed with this initial side and with this terminal side. You could start here, just move that short distance and end up here. There's another way to start here and end up here, and that's if, like a clock, it goes all the way around and ends up there. Then it would be 360 plus whatever this angle is, which is like 30 degrees. Okay, so those are the two angles where This is the starting point. That's the ending point. Whatever. All right. Congruent. You can talk about angles as being congruent, and that means that they're the same angle. They're geometrically identical. So the way that you would write that is, if you're comparing angle A and angle B, you can use the symbol for congruent, okay, which is that. Or you can use the equality of angle measurements, and you can say it's equal, but this time we're talking about actual numbers. So the measurement of angle A is equal to the measurement of angle B. All right, let's look at the names of these angles. If you start here and end up here, that is called a straight angle, or like a straight edge, but straight angle. And you already know that that's 180 degrees. This is called a right angle. It's indicated by the square, and that is how many degrees? 90. Yay. This is called acute angle. Remember, it's so cute because it's little. And this is called obtuse angle. And remember, it's called obtuse because it reminds me of the word obese. That means it's a fat angle. It is greater than 90 degrees. All right, let's go over supplementary angles. Supplementary angles mean that the angles add up to 180 degrees. 180 degrees is a straight line, so it's this. So this angle X and X plus 40 is equal to 180 degrees because X and X plus 40 are supplementary angles. So then you could figure out what X is, right? All you would have to do is X plus 40 equals 180. That means 2X plus 40 equals 180. And you could keep going and figure out what that is. X is eventually equal to 70 degrees. Okay, what about complementary angles? Complementary angles are awesome because they add up to 90 degrees. So here they give us two angles. One is Y, the other one is Y plus 30, and we know that that has to equal 90 degrees. Y plus 30 is 2Y plus 30 is 90 degrees. 2Y equals 60. Y is 60 divided by 2, which is 30 degrees. Sweet. What about vertical angles? Vertical angles are these angles here that are formed by intersecting lines. And guess what? They're equal. So this is the same as this. So if I wanted to solve those, I would do Z is equal to 3Z minus 80 degrees. Okay, and then I'm going to isolate the variable, so move minus 3Z to the other side. That cancels out, and then I add those. So 1Z minus 3Z is negative 2Z is equal to negative 80. Divide by negative 2. Z is equal to 80 over 2, which is 40 degrees. That's how you would solve that. All right, let's go over betweenness, tick marks, and assumptions. One point is said to be between two other points only if they lie on the same plane. So you could say here, point C is between A and B. X is not even related to those, so you can't say it's between anything because they're not on the same line. Okay, we're going to use tick marks to show that things are equal. So if you want to say that AB, segment AB is the same as CD, you put 2 tick marks there, 2 tick marks there, they're equal. You can do the same thing for angles. If A is equal to B, this has 3, this has 3, that means they're the same. You cannot assume that they are the same even if they just look the same. C and D are the same here, E and F are the same because they only have 1 tick mark. Okay, these are the same and these are the same. Make sense? All right. Now, here are some things that you can assume when you're doing problems. If the line looks like it's a straight line, you can say, okay, that's a straight line. You can assume that. But do not assume that you have perpendicular lines. If you have 2 lines that look like this, You cannot assume that that's a right angle. It's not a right angle unless they tell you it's a right angle. You can also not assume that line segments are equal or greater than. Like which one's bigger between this and this? Who knows? If it looks bigger, you can't assume. Sometimes it's an optical illusion. So don't just assume that one is bigger than the other. For example, is BD longer than this? You can't assume that. You would have to figure that out mathematically. But you can say that this line is straight. You can say that these lines are straight. But you cannot say that this is a right angle. It might look like one, but it's not. You will only be able to assume that if they put that little square there. Okay? So, yeah. Those are the things you can assume and not assume. Okay, let's go for triangles. Oh, I love triangles. Triangles are some of my favorites. All right, let's start with this triangle. This is an equiangular triangle. Equa means the same. Angle means that all the angles are the same. Okay, so that's great. And what about an isogonic triangle? This one is isogonic. Okay, let me erase that. Okay, what does that mean? Isogonic means that at least two angles are equal. The other one doesn't have to be, but it has two that are the same. If at least two are the same, it's going to be isogonic. Okay. This one is a right triangle because it has a right angle in it. If all of the angles are less than 90, so this is less than 90, this is less than 90, then the whole angle is acute because it's a cute little triangle. If there's even just one angle that is a fat angle, then it's called an obtuse triangle. This is supposed to be a straight line. It looks kind of warped on my picture. All right, you can also classify triangles based on the length of their sides. So this is how you classify triangles based on their angles. All of them are the same, equiangular. Two of them are the same, isogonic. One is a right angle, right triangle. They're all acute, or one's obtuse. Okay, you can also say, look at their lengths of their sides. Here's the tick marks, 1, 2, 3. All of their lateral walls are the same, it's equilateral. What if only two are the same? It's an isosceles. Iso means the same, and celes means two of the sides are the same. Okay, and scalene, what does that mean? It's a triangle where all the sides are different. So here's 1, here's 2, here's 3. None of them measure the same, so that's a scalene. Okay, that's how you classify triangles. Now, let's do angles. Okay, this part is super fun. I love this part because it's so satisfying when you know all of these angles. Let's say you've got two parallel lines. Here's a line, here's another parallel line. And then you've got a transversal line that is cutting between those parallel lines. What you end up with is 4 angles here and 4 angles here. You end up with 2 sets of 4 angles. This is how I think of this. This line is separating a parallel universe. There's one parallel universe on this side, and then there's like another evil universe on this side. Okay, so if you think about it that way, sometimes that is helpful, and I'll show you why in a little bit as we go over some of these angles. Okay. You'll notice that a lot of these angles are the same. You're going to have an angle here, angle A, that is the same as this one in the parallel universe. This angle is also the same as this one in the parallel universe. Of course, since this is 180 minus A, then it makes sense that B is going to be the same as B in the parallel universe because it's just 180 minus A. So 180 minus A is going to be the same as 180 minus A. So the B's are the same. The A's are the same. The B's are the same. So if you put numbers, all they would have to do is give you this number, and you could say 180 minus 130 to get that number, And then you have all 4 angles. And then it turns out you have all 4 of these too. They really only have to give you one, and then you can figure them all out. 90 plus 90 is 180. So if you know that one of them is a right angle, then they all are. And same with this. Cool, huh? That's why it's so fun. Okay, a couple more vocabulary words. Interior angles are these angles right here in between the parallel lines. So these are the interior angles. Interior angles. Interior angles. Exterior angles are the ones outside of the parallel lines. So exterior angles. Exterior angles. Exterior, 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 exterior. Okay, cool, huh? All right, let's move right along. We have a couple more vocabulary words. Alternate interior angles. So alternate interior angles. Remember the interior portion is anything in this area. So an alternate interior angle is going to be this angle because it's on the inside. Which one is the same as that angle? It's going to be this. Why is that the same? Because it's the same as this, which is the same as this and this. Okay? Okay, but the interior ones that are the same are those. There's 2 more that are interior and the same. Let's see. Okay, the other set that's interior and the same are this, A. What's the same as that on interior side? That. Alternate interior angles. Alternate interior angles. Okay. What about alternate exterior angles? Alternate exterior angles. So exterior means they're outside of their parallel lines. So it would be this area and this area. What are the alternate exterior angles? Okay, so it would be this A, and what's the alternate? This A. Okay, and they're going to be the same value of the angle. They're going to be equal. Okay, and what about another set of ulterior, oh my gosh, I can't say it. Alternate exterior angles. It's going to be this B. What's the same as that? This B. Okay. If it's an alternate, that means it's the same. Think about a play. If you're playing like Snow White or something and you have an alternate, she can also fill in and be Snow White. They're going to be the same. Okay. What about corresponding angles? Corresponding angles are angles that have corresponding positions. So that's different. That means that their position are the same. Kind of like if you're doing a tic-tac-toe, I don't know, it's like a mirror image. So here's A. What is going to be the mirror image of that? It's going to be this A. I don't know if that makes sense, but it's sort of in the same position. Like if someone's trying to copy you down below, they're going to put it in the corresponding angle. Okay, so if you put your B here and someone wants to correspond and copy you, they're going to put it here. They're just like a copycat. They're just doing it in the same spot. So corresponding means they're trying to be a copycat. What if you put B here? Where's the other corresponding angle? It's going to be here. Copycat. Okay. And then what if you put your angle here and someone tries to copy you? They'll put it here. Okay. And it turns out corresponding angles also have equal measures. So really someone's trying to copy you because they're going to have it exactly the same. And there's some rules to remember. Like if 2 parallel lines are cut by a transversal, then corresponding angles are the same. Okay. If 2 parallel parallel lines are cut by a transversal, then each pair of alternate angles are the same. They're congruent. And if two parallel lines are cut by a transversal, then each pair of alternate exterior angles are congruent. Which ones are those again? That is this one and this one. So they're going to be the same too. So this one's going to be another B. So there's a lot of the same, you can just figure everything out. So it's really kind of cool. This is going to be another A. This is going to be another A. This is going to be another B. Cool, right? Alrighty, let's go over area and sectors of circles. If you need to take a break, you can take a break and come back because I know this is a butt ton of information. Let's go over areas and sectors of circles. Okay. Let's see. Okay, the area of a rectangle. Start here. What's the area of a rectangle? You should know it. Length times the width. This is the length. This is the width. Bam, easy, just like that. What about the area of a triangle? 1/2 the base times the height. This should be dripping off your tongue. This is the base. What's the height? The height is where it's 90 degrees up to the top of that other line. 90 degrees. So 1/2 the base times the height. Let's look at this triangle. This is the base. So 1/2 the base. Where's the height? The height is where it's 90 degrees. Since those are not 90-degree angles, you have to draw one. Draw a line. This height. This is the height right there. What if it's an obtuse triangle? What's 1/2 the base times the height? You can call this the base right here. But the height is going to be an imaginary extension with a 90-degree line. This is the height. Get it? So it's the height is measured outside the triangle, but this is still going to be the base, just from here to here. So 1/2 the base times the height. So you just have to know what the base and what the height is, and sometimes you have to extend it out. Sometimes it's the middle of the triangle, but it's whatever is 90 degrees. Okay, do you remember the area of a circle? I hope you do, because the area of a circle is pi r squared. Okay, do you remember the circumference? The circumference is if you took a piece of string and went all the way around the circle, how long would that piece of string be? It would be pi times the diameter. That's kind of cool. You could measure the length of string you would need to go around a circle just by knowing the diameter and multiplying it by pi. Or you could know the radius and multiply that by 2. That gives you the diameter, as you know, and then multiply that by pi. So this is the same formula. And memorize those. You got to know them. You got to know them, Maddie. Okay, what's an arc? Remember how Noah built an ark? This is a mathematical arc. A mathematical arc is when you have a circle like this. You pick 2 points on it. So you've got a point here and a point here. An arc is 2 points on a circle and all the points in between those 2 points that lay on the circle. That's an arc. So this segment is called an arc. Now, if you draw 2 radii that connect the arc with the center of the circle, this area enclosed, the area of that, is called a sector. Okay, so you can draw a sector like this too. You've got that, you've got that, you've got this arc, and maybe you know the angle is 18 degrees. That's the central angle. The sector is the area of this entire section in between. This would be 18 degrees of an arc. Okay. Sweet. This is stuff you need to know. This is stuff you need to know. Guess what? You can calculate the area of a sector. We're gonna learn how to do this. It kind of looks like a triangle, but if you just did a triangle, you wouldn't get all that space because this is curved on that end, right? So to calculate the area of a sector, this is what you do. It's going to be kind of like pi r squared. So you've got pi times the radius, which is the center of the circle to the arc. So that's 5 centimeters. You square that, so that's pi r squared. But then you're going to multiply it by this number of degrees as a fraction over 360. That makes sense to me because a whole circle is 360 degrees. Okay? But this is like a certain percentage of the pi. And the percentage is 18 over 360. So the area of a sector is 18 over 360. It's not 18 every time. It's whatever degrees. It could be 30 over 360. It could be, oh, look, this is cool. If it's 360 over 360, that just turns this into 1. And then you get the area of the whole circle, which is pi r squared. Whoa, that's cool. So it's just a percentage of the circle. And the percentage of the circle is that angle over 360. That totally makes sense. I love it when math makes sense. Don't you love it? Oh, that's so cool. You could also calculate the length of the arc by using that circumference formula. Remember, the circumference is 2 pi r, so that's 5 centimeters, 2 pi r, times the certain percentage of degrees over 360. So it's kind of doing the same thing. Instead of calculating the length of the whole thing, it's just the percentage of the circle. Whatever degrees over 360 times 2 pi r. That gives you the length of that arc. Oh, that was so cool. All right, we're going to do an example just to make sure that you understand that portion of it. Okay, let's look at this picture right here. And then it says, the measure of the central angle of the unshaded part is 126 degrees. So that is 126 degrees. Now it says the radius of the circle, so from here to here, the radius is 2 square root 5. Of course, they can't just give you a number like 25. No, it has to be 2 square root 5 meters. Okay, find the area of the shaded region. So the area of the shaded region, just think of the area of a circle. An area of a circle is pi r squared, but it's not the whole circle. It's just a portion of the circle. What portion? It's going to be some portion over 360. Is it 126 over 360? No, that would give us the area of the unshaded part. They wanted the area of the shaded part. So it's going to have to be 360 minus 126. And then if you do the math there, you get 234. So the area of the shaded part is 234 over 360 times pi r squared. Instead of r, we're going to plug in what they said the radius is. And what they said the radius is 2 square root 5. That whole thing has to be squared. So just do the math on that. You'll end up with 13 pi meters squared. Sweet. All right, let's do some concept review problems. These are really hard problems, but these are the type of problems that show up on ACT and SAT tests. So I want to make sure that you know how to do them. This is the last section that we need to go over, and then you're done and you can do your homework, okay? I know this was a really long lesson. Thank you for hanging in there with me. Here's the concept review problems. If the answer is A, or A is bigger, then that means quantity A is greater. Just bear with me here. This is going to, if B is greater, then the answer is going to be B. If the quantities are the same, the answers are going to be C. And if you don't have enough information, the answer is going to be D. All right, so with that in mind, let's look at these examples. Example 1.2, this is like abstract math. If X and Y are real numbers, so they give you two numbers. You've got X, you've got Y. Now it says, if X is greater than 0 and Y is less than 0, compare these two things. So here they're saying on option A, you have X plus Y. Option B, you have X minus Y. Which one's going to be bigger, A or B? Okay, so they didn't give us a ton of information, but they told us that X is greater than 0. That means X is going to be positive. It's a positive number. And they said that y is less than 0. That means y is going to be a negative number. If you add a positive with a negative number, what might you end up with? You're going to end up with something that's less than x, right? Something that's less than x. So if this is, I don't know, because you're going to end up subtracting a number. Does that make sense? Now let's think about b. What happens if you subtract a negative number? If you subtract a negative number, that's the same as adding a positive number. But you know that it's going to be a positive thing that you're adding to x, and so x is going to end up bigger. Here, x is going to end up smaller because you're adding a negative. Here, x is going to end up bigger because you're subtracting a negative. That means you're adding a positive. So which one's going to be bigger, A or B? The answer is B, because when you subtract a negative number, you end up adding a positive. Does that make sense? They did it mathematically in the book, but I think it makes sense just to think it through. Let's do example 1.3 and see if this one makes sense. Here they tell us that x and y are real numbers and that x is between the numbers 1 and 6. That's what this means. X is greater than 1 and it's less than 6. So it's got to be between 1 and 6. It could be 2, 3, 4, 5, or it could be 2.1, or it could be 3.14, something. We don't know, we just know it's in between the 1 and 6. They also tell us that y is between 1 and 6. Now they want us to compare these things. X minus y or y minus x. So x could be any number between 1 and 6. Y could also be any number between 1 and 6. So we have three options here. The three options are x could be bigger than y. If x is bigger than y, then a is going to end up being a positive number, and b is going to end up being, let's see, y minus x is going to be, is that going to be a positive number? No, it's going to be a negative number. It's going to be a negative number. So that is what would happen if x is bigger than y. What if x is less than y? If x is less than y, then this is going to be a negative number, and this is going to be a positive number. Okay, so we still don't know which one is bigger. What if x is exactly equal to y? Then x minus y, that's going to end up being 0, and y minus x, that's going to end up being 0. So those two things are equal. So it could be that a is greater than b, could be b is greater than a, or a is equal to b. So we don't know. So the answer here is going to be D, not enough information. We can't compare two numbers. Info, not enough info. Okay, let's do the next example. They give us two intersecting lines, and they name these angles, KLMN. All right, so they want us to compare A and B. A is going to be K plus L plus M, so it's this angle. B is going to be 180 minus N. Remember, 180 is a straight line, so it could be this straight line, 180 minus N, which is just, that's the same as M. So which one's bigger? Instead of that, you could just call it M. K plus L plus M, or just straight M. Of course, K plus L plus M is going to be bigger than just straight M. So A is bigger. So the answer is A. That makes sense to me. Let's do example 1.5. Here we have, they tell us, and they have to tell us that they're parallel lines. You can't assume that they're parallel. That ZW is parallel to XY. They want us to compare the areas of two triangles. Ooh, I love this problem. This is awesome. Okay, which two triangles are we looking at here? We're looking at WXY, that's this one, this triangle. So if you were choosing a piece of cheesecake and you wanted the bigger one, would you take a piece that looks like that? Or would you take the XY, that's this one? And it turns out that what is the formula of a triangle? The formula is 1/2 the base times the height. The base on both of those is XY, because that's the bottom of both those pieces. What's the height of both of those? The height is the 90-degree height. And guess what? 90 degrees would be out here. If these lines are truly parallel, the height is going to be the same. So that means they're equal. A and B are equal. You could choose either piece of cheesecake. You'd end up with the same amount. So the answer is C. They're equal. Sweet. Guess what? That's the end of the lesson. Surprise. Do your homework, Addie. Love you. Bye.